Alexis, and in this video I'll be talking about Unsloth. So I'll be running continued pre-training, and I'll be using a Unsloth model using the Mistral architecture and 7 billion parameters. It has been quantized, so it's a little bit faster to download and upload or run on your computer and in Colab using the T4 compute environment. And this is the prompt that I'm using. It will grab the article from Wikipedia and then use it to format the data during training. So it'll put the title here and the article here, and I'm using Spanish, so I translated it into Spanish. And since this model is not trained specifically for Spanish, I'm going to try and shift it so that it can better understand Spanish using continued pre-training. Continued pre-training is a good idea when you're trying to alter the model significantly, since it exposes more parameters and allows you to basically train more data. And Wikipedia has lots of data, and so Wikipedia is a really good tool to use, or data set to use when you want to train a language to a model. So this is the .es, so it's the Spanish file of the Wikipedia dataset, and this is where I pre-train. So the Unsloth trainer is initialized here, and then you add your arguments. And so for max steps I put 60, so it'll train 60 iterations, as you can see here. And then you can also fine tune it using Unsloth, and I use the Alpaca and GPT-4 dataset. So this step is, I guess, optional if you're using continued pre-training, since here's where you've already trained the model using continued pre-training. When I'm doing the fine-tuning, I change the prompt, so it's a different task where instead of trying to use Wikipedia to learn a language, it is trying to have the model follow an instruction and give a certain response. Typically this is in a domain where a question is similar to other questions in the dataset. So if you're doing Alpaca dataset, Alpaca typically is a general dataset where the model responds to a variety of tasks. So it's a very good general dataset for instructions, where there's, for example, here this is a sample. It talks about recycling. So the whole dataset is not about the environment, but the model will learn a little bit more about how to respond to questions instead of simply how to understand facts from Wikipedia. So that's the difference between instruction fine-tuning and the continued pre-training. Both of them have 597,000 parameters that are available if you are training the model. And given that I'm only using 60 max steps, the whole data set is not being used to train the model, and so it will run faster. If you were to set max steps to none, it would run the whole duration, which will take at least a whole day or more, depending on your compute environment. And then after, you can upload it to HuggingFace, which I did here, and then you can evaluate it. And then for the Unsloth fine-tuning part 2, this is further fine-tuning. This is relevant to continued fine-tuning. So in the continued fine-tuning, you can use Unsloth training checkpoints to pause the training. So as I told you earlier, there's a lot of parameters that are exposed, and the data sets are huge if you're using Wikipedia. So training would take a really long time, and you will probably reach a bottleneck where you can't process all the data. So you can pause the training and save the checkpoint, and then continue it at some other time if you save the checkpoint. So as you can see here, phase 1, you train it normally like in the previous. And then here I changed the steps to 30. I altered the save strategy and added save steps to 50. And I'm also using the alpaca chat dataset similarly to the Unsloth fine-tuning pretraining. And then I mentioned earlier that the fine-tuning part 2 is more fine-tuning that I did on the earlier model. And in this notebook, I saved it to HuggingFace. And you can save the quantized model for inference. So this is for immediate inference. And then if you push it to hub without gguf, then this is, and then you add the save method LoRa, it will only save the fine-tuned parameters instead of the entire model. So this is, I guess you could say, another way of checkpointing. So if you save the LoRa adapter model here, then you can continue fine-tuning if you load it over here. And then you can merge it with the earlier quantized model after further continued fine-tuning. And so phase 1, you normally call trainer.train when you train, and then it will train up to 30 steps. And then in fine-tuning phase 2, something interesting that I found is you use resume from checkpoint true, and then it will resume training. However, it does not go to 30 like in the first phase. You would have to have it in a loop and then continue calling this command so it can train each iteration individually. I'm not sure how much added time it adds by doing this. However, for me it felt similar time frame of like 7 minutes to train in this way. And then after I save the LoRa adapter model again to the same HuggingFace repo. And then now I will show you a little bit of the Quen 2.5 coder C# alpaca model and how it did after this fine-tuning. So originally the Quen chat model, the base model provided by Unsloth, after fine-tuning with the C# dataset, responded kind of strangely. I messaged hello and it responded with code, and it seemed to be completely random. And then after using the new Quen 2.5 coder C# alpaca instruct model that I uploaded, and this is the quantized model, I said hello and I have a question about the GPC framework, and now it's responding, and it's responding in Spanish since it was trained on the Wikipedia Spanish dataset as well, which is kind of cool. And then, this wasn't trained on the Wikipedia Spanish dataset. It was trained on the Alpaca GPT Spanish dataset. So it was fine-tuned with the C code and then fine-tuned with the Alpaca code. And so now it has an ability to respond to requests of like a variety of domains like code, and interpret it and then use its background knowledge of code to use code to explain its response. So earlier I said hello, it didn't really respond in English because it wasn't having the alpaca Spanish instruction data set. And then now it knows a little bit more about variety of coding topics, maybe because of alpaca, or maybe because of the Quen25 coder base knowledge. And it responds in code whenever it tries to explain an idea. So I think the fine-tuning did really well, and Unsloth is a really good tool to use for continued fine-tuning and continued pre-training.